You also have to think about the type of data then that we need to be able to extract, from the, call it 10 million route database. Maybe that's simply the domain that subscriber lives within, right? And now the session border controller can help you to reach that domain where it's not necessarily doing the query of a global view of the world, just like a soft switch shouldn't be doing any sort of a translation or query the global view of the world in a more IP-based network.
Any other question?
So, for example, in a network, if you have like multiple soft switches, but all your egress logic is the same, I would think it would make much more sense to have the routing intelligence and the egress point, especially the SBC.
Are you talking class 5 soft switch, or?
Yes.
Okay, so you have multiple features
and
yeah, not only like class 4 soft switches, like in a service provider network, there may be like many kind of unified messaging system or standalone conference server. They are all set-based, and they all have to originate from like this PSTN or IP network. So this SBC naturally is in the core path, and it is have like routing intelligence embedded with that, so it's easier for the service provider to not rather have the core routing be managed by some other devices.
No, I think we're confusing, where the routing logic exists, or the database exists, with who's implementing the policy. So, as I think SBC vendors will tell you that the SBC is very good at implementing the policy. But you don't necessarily need to embed the routing database inside the SBC. It's a different thing. So you can get everything you want. I mean, you can even just get the soft switch to make all the decisions, and you have a simple bilateral type connection on the SBC, but you're going to lose some advantages the SBC can bring in terms of looking at the loads on different interfaces, recovering from failures, and things like that. There's a lot of advantages we can bring to the table that way. So as a point in the network which has more information about the connections with which it can make policy decisions, that it's getting where the policy database is coming from another server, it's a good architecture, right? The SBC is essentially an enforcement point, and it's probably the right device simply because it has more information to make those decisions.
But it does make sense. If you have multiple class 5 switches, you can very simply use your SBC as a tandem class 4 point that knows, okay, these DIDs are here, these DIDs are here, my termination partners are out here, and certainly on an inbound call, it's a very simple routing based upon your DID allocations. Inter-subscriber calls are basically the same. The only kind of difficult routing lookup that you have to do is maybe on outbound calls where you're trying to save some money. And that's where you could go out to the VPF with an email lookup or to TransNexus or somebody like that to say, hey, I really don't want to store all of these possible termination points. I just want to go do a lookup and find out where to go.
Yeah, we've seen a least cost routing situation really go to a least cost implementation situation, right? Where now, right out of the gate, you may have a small number of devices, and you may want, you don't have a large amount of data, right? So that the scalability factor is not there. But certainly that that device should be capable of either locating that data within itself or use the same techniques and queries and policies and to locate that data externally. The last thing, it's the same with simply policy servers, maybe on the access side. It's, they keep track of network bandwidth, right? You can do that on a single device, and you can say 50,000 users all come into one device, and we'll sort out the bandwidth, maybe give them 2 calls per person or 100K per person, and you can implement policies on that device. Well, then we get to millions of users. Now we've got half a dozen different edge devices, and you have no way to pool that data. If they fail over to a different device, you don't know whether they were allocated 100K on the other device, right? So now you have to centralize that information, and it becomes a central point of query and state information. So you need to share that data between multiple devices, and that's where a device like TransNexus makes perfect sense and helps you scale out.
Oh, my question was more because I guess it was a discussion before that you have a database that didn't have any state on it, But through DNS, you can actually find out what the state are of those routes and be able to reflect that in your answers back. Is that part of what you guys? I know you probably more from the SBC side, but from the routing database, you can have more intelligence than just state, static type of.
Well, I think the point is that in general, you don't need that because you kind of want to. You have the stateful information at the SBC layer, and if you have it there, why replicate it at your routing database if you're going to do a DNS or need to lookup? Tends to be just a lot faster that it's just getting information from the database and responding back with it, not having to keep track of what else is going on in the network. It's simply doing ANE, DNS, get the information and get back the route.
But it depends on the scale of your network, right?
Oh, true.
If that device is not the same device, so you want to have that information somewhere else that knows that different SBCs are available or not available, different switches are available.
Sure, you can overload the information that comes back from the routing database, right? You could say, well, maybe there should be a group of devices that are reachable, and then the SBC can help determine what that group of devices is. Maybe it's a domain that you're trying to reach, or maybe you simply want to pass the SBC trunk group information to make it parallel to your PSTN implementation, right? So that then the SBC can help make decisions based on that.
I think if you make that database or that device stateful, it's going to be complexities and scale issues.
You were just bringing out a point where the separation of the data and the routing intelligence, where the routing intelligence is derived from the policies, and the policies being executed in the SBC. Do we also see a picture where even for a single call or the session that is being initiated, the routing policy itself, the intelligence itself, will be distributed? It won't be like a single SBC doing the whole thing, but rather depending on what the state the call is in, where, right?
I think in a lot of networks you have distributed SBCs at your edges.
Right.
And so if a call comes in on one edge and it's going to traverse out the other edge, that could involve two stateful SBCs and maybe a stateless routing engine. Is that what you were describing?
Yeah, you will end up having distributed intelligence, basically. It's not going to be one entity, even executing the policies themselves.
Yeah, I believe it's already implemented. I mean, if I think in the iBasis network, that's pretty much the way it is.
Yeah, it's an interesting issue because the inbound call will come through the stateful SBC, be routed by the routing logic, and then be basically told to egress SBC of the network. So if you have a large private data network, you may go transit your private data network between New York and London to then go out your London colo with an SBC. And that device would have some intelligence to say, okay, I'm going to try VT, this guy, this guy, this guy, this guy, based upon the call inbound to it from the other SBC in your network. I think that actually makes a good case for having some least cost routing intelligence distributed around your network, because then the other SBCs don't need to know about just your termination partners within the UK or something like that. So your termination, your least cost routing may be localized to your particular location colo to say, I don't need to know about what's going on in Hong Kong, I just need to know about what to do with calls coming to London.
He answered my question in the distributed knowledge within the SBCs for egress.
Yeah, and I think it's actually a good point, because quite a few of our customers do that, where they have many different POPs, and the routing is really dependent upon that particular POP. It doesn't really need to know about the rest of the world's routing. So it comes down to more or less the class 4 switch within that country or within that region.
So there are a couple things you'd want to avoid, though, is that you don't want to have certainly a lot of different options. You don't want to have, the more you can accomplish in a single cycle, right, the less processing work you need to do, and the more you can sort of obtain that information and maybe your database look up and share it amongst the devices, the better off you are. You don't want to get into a situation where